Hi everyone. This is an example of deriving formulas starting from percentage and molar mass. Here we go. Caffeine is 49.48% carbon, 5.15% hydrogen, 28.87% nitrogen, and 16.49% oxygen by mass. The molar mass is 194.20 grams per mole. Determine the empirical and molecular formulas. When we're asked to figure out formulas, we have to pay attention. Sometimes we're only going to be asked for the molecular formula. Sometimes, like this question, the empirical and the molecular formula. Questions of this type come in two varieties. Like this one, we were given percentages and the molar mass, but sometimes we might be given mass and the molar mass. So the steps to follow are very similar between the two, but we do need to recognize which specific style of question we have. This one more time is percentages and the molar mass. Our first step is to convert these percentages into decimals. We need to do that for each element. So I have carbon, it's 49.48, which we need to divide by 100. You might not even need to show that step. You might be able to do that conversion, that division, right in your head. The same for the hydrogen. It's 5.15. You need to divide that by 100. For the nitrogen, it's 28.87. For the oxygen, 16.49. For each element, take the percent and convert it into a decimal by dividing by 100. You yourself might like to show that answer. I would encourage you to not. Okay? Our next step is to multiply by the molar mass. Multiply by the molar mass, which is right here in the question, 194.20. Gets a little bit repetitive. But that's okay. Take the percentages, convert them into decimals by dividing by 100, and then multiply by the molar mass, which is right in the question. The third step is to divide by each element's individual atomic mass, which we're going to pull off of the periodic table. For carbon, here we're going to divide by 12.01. For hydrogen, 1.01. For nitrogen, 14.01. And for oxygen, 16. Now we're ready to calculate. Lots of buttons to push. Let's be careful. 49.48 divided by 100 times 194.20 divided by 12.01. This equals 8.0008. What we need to do right here is round these answers off to the nearest whole number. This one is 8.000. How about the hydrogen? 5.15 divided by 100 times 194.20 divided by 1.01. 9.902, round that off to the nearest whole number, 10. 9.9 rounds up to 10. What about the nitrogen? 28.87 divided by 100 times 194.2 divided by 14.01. 4.001. That rounds off to 4. And last, the oxygen, 16.49 divided by 100 times 194.20 divided by 16. 2.001. Rounds off to 2. These answers, these whole number answers that we calculated, are the subscripts of the molecular formula. So here the molecular formula. Look at what we got. Let's put all the pieces together. C8, H10, N4, O2. That's the molecular formula. We used the molar mass from the question in our work. This answer was determined by the molar mass. To figure out the empirical formula, we're looking at the subscripts in the formula, in the molecular formula, and we're trying to reduce them down. What's the greatest common factor of 8, 10, 4, and 2? It happens to be 2. So we can take these subscripts and divide them all by 2. We can simplify the molecular formula down to the empirical formula. It becomes C4, H5, N2O. The empirical formula does not have a strong relationship with the molar mass. It does have a whole number relationship with the molecular formula. Questions that ask us to derive the formula, they come in 2 big styles. One style that gives us a bunch of masses and the molar mass, and this style where we have percentages and the molar mass. Here, when we have percentages, our first step is to take them and convert them back into decimals by multiplying by 100. We did that for each element. And then we multiplied by the molar mass. It was the same each time. The molar mass came from the question. Then we divided by each element's atomic mass, which came off of the periodic table. 14.01 for nitrogen, 1.01 for hydrogen. The answer that we get there, we must round off to the nearest whole number. No decimals down here. And these values become the subscripts of the molecular formula. Some questions will only ask us to determine the molecular formula. Here, we had the additional step of determining the empirical formula as well. There we looked at the subscripts and looked for the greatest common factor to reduce those subscripts down to the empirical formula. And I hope that helps.